So some tips, I wrote out a few tips. And again, I'm kind of repeating myself, but I cannot say this enough, right? When you're doing DDT of both sides, every variable must be differentiated. Every variable, right? Do not substitute in given values for a variable at a particular point in time until after you have differentiated. I know it was in the directions, but a lot of people do it too early. So this is super important that I just highlighted. If you substitute in too early, the variable becomes constant. And when you take the derivative of a constant, it's going to be zero, which is not helpful in these problems. Only have values for parts of the equation that are always constant. So in the previous example, in example 2, the ladder didn't change in length. That is a constant, that value you put in. But if that length had changed, I would have to put a variable in for it. Only have two values for parts of the equation that are always constant. Only have values for parts of the equation. Not two. What am I saying? If there are units, track them and check if they make sense at the end. Okay. All right. So Carly walked to South Mountain Water Reservation, and throws a rock into the lake. Since the lake is calm, ripples in the shape of concentric circles are formed and in the water, on the water. If the radius of the outer ripple is increasing at a rate of 2 feet per second, at what rate is the total area of disturbed water changing when the radius is 5 feet? So this essentially, if you think about how ripples in water work, you are going to use the area of a circle. It's going to have to be the total disturbed part of the water is the circle that has, depending on how far out the ripples have reached. So I know I need to use the formula for the area of a circle. So the area of a circle is pi r squared. Now it's saying here the radius of the outer ripple is increasing at a rate of 5 feet per second. At what rate is the total area of disturbed water changing when? So I'm telling you that dr dt is equal to 2 feet per second. And I need to take the derivative. Do not put the 2 feet in yet, right? And it's also asking what's the total area? What's the rate of change of the area of disturbed water changing? Try that again. At what rate is the total area of disturbed water changing? You guys know I get excited, so then I can't read. When the radius is 5. So that is the instant. That one we have to wait with, where it says the radius is 5. That's at the end of the problem. So now we're ready to take the derivative, d dt, with respect to time of both sides of the equation. So that's going to give me dA dt. That's the rate of change of the area now with respect to time. And then pi, don't forget, is an actual constant. So this is going to give me 2 pi r dr dt. By the way, just a little aside. Now I'm sidetracking and I know that and I'm sorry. But I just want you to notice this here. See if this makes sense to you. The area of the, if you think about ripples in a lake, the area of the circle is increasing, right? So essentially it's changing by an infinitely many new circumferences. And if you think about the formula for a circumference is 2 pi r. The area of a circle and the area or the circumference are related in that way. So if you can imagine that you draw a new circle around each new circumference, then eventually you're going to draw a full area. That's basically what this is saying. So it's adding a new circumference on top of the next one out to create this area of a circle. So it is really neat. When you take the derivative of the area of a circle, you essentially get the circumference area, but it makes sense. It makes sense that to increase the area of a circle, you have to add more and more circumferences to the circle infinitely many times to create an even bigger circle. I don't know if I'm speaking nonsense, but to me, it makes total sense. It's so cool. Now you can see how the area of a circle and the circumference of a circle relate to one another. All right, so now I've taken the derivative. Now we do the instant. So then we say, okay, I'm actually interested in when the radius is 5. So I'm going to write when the radius is 5. I want to know, and it says, what is the rate of the total area? So I really want to know dA dt. That's what I want to know. What's that? So I have dA dt is equal to 2 pi. The radius is 5. And I'm also told the rate of change of the radius, which is 2. So that's going to equal, let's see, 20 pi. And my units in this case are feet per second, and it's a rate. And it's not feet per second, it's square feet because it's the area of a circle. So be really careful with that, right? So the area of disturbed water is changing at a rate of, or it would even be better, instead of saying changing, maybe I'll say increasing at a rate of, okay, I have that twice, of 20 pi square feet per second. It's super important.